I'm busy setting things up. It is amazing how YouTube likes to make things so complicated. I just want to track messages, and for some reason, it's not allowing me. I have a feeling YouTube changed something recently, which is not would not be surprising at all because YouTube loves to be a giant pain in the ass. Okay. It's been 4 minutes. If I can't figure it out, then sorry YouTube, you'll just have to be not present on here. Maybe if I do a fresh sign in. So it's annoying. It's very annoying. All right, now will you load? Yes, I. All right, now I need to do this. Okay. All right, there. Now we're logged in. Thank you. So now we're logged in. Now then, can I select my source? Activate. All right, I think we're connected. Okay. All right, we're connected. We're connected. So let's go ahead and start. All right. Hopefully everything is working. I will have to keep an eye out if it's actually, you know what? Because I am convinced it's not going to work, I'm gonna I want to pop out the chat real quick just to be safe. That way I'll know. So let's see, that should be on, that should be on. This should be connected. Okay, yeah, this should. All right. This tool requires sign in to access YouTube's. Yeah, YouTube changed something. YouTube. Will you guys stop being a massive pain in the ass, please? YouTube is probably like one of the worst places to try and stream. They always make it extremely complicated to do anything, and I don't know why. What we're going to do is we're just going to do a standard grab of it. Like I'm already logged in. I don't know what else that this wants. I really don't. Hmm. All right. Anyway, let's just, as I said, if push comes to shove, well, I'll figure it out later. It claims it's connected. We'll find out. For now, let's just start coding. So here's the old code. If you remember last time, we were going to start building up our animator code. In fact, you can see here it is, the animator code. The idea was that all of the stuff that we had, the import. So we made a bunch of importers. These importers will go in, find all of the stuff that we want, and organize them out. And then from there, what we were going to do is we were going to start using an animator, which will start compiling all of the images to run stuff. But we started running into some issues because of the fact that, we started running into some issues, largely because I kind of want to be able to do a lot of things. I want to be able to modify each individual component. I want to be able to modify the composite of all of the images. And I just wanted to have a bit more control over what's going on with the frames. Because of that, we started looking at my old code. Here it is, Framer. And after going through this and thinking about it, I think what we're going to do is we're going to modify this Framer code and use this as a means for doing the animations. What this means is that for our image manipulation code right here, if you remember, originally I was going to separate or combine them together. So it'll be like, oh, if this is an image, then run this. If this is an image, do this. If there's an empty array, do that. By doing it this way, I could kind of keep everything together. However, given that we're going to be this is probably going to have to be separated out. I feel like what the best I think I can do is, if you look, this is at least what I am currently thinking. Right now, once we use our importer, we generate this dictionary. Where is the dictionary? All right, well, okay, I don't see the dictionary, but we generate a dictionary, and that dictionary contains all of the files and it contains all of the images. We probably should load it up for ourselves. Actually, we should probably, yeah, let's get rid of that. Here it is right here. Okay. This is our image size. Here's our folder. Here it is right here. Folder dictionary. Here we go. So as you can see here, we end up taking all of our files. We generate this dictionary. It has our different costumes here at the top. And then we go down into the different emotions. And then from here, we'll then break them down into the animation components. And then finally, it's all of the frames. As you can see here, we have 7 and 1, and pretty much we composite all of these into our frame. So with that in mind, instead of having these be lists, I feel like the next step would be to have all of these get loaded into the Framer module, And then this will then, instead of this being a bunch of, as I said, lists that point to a picture, instead it's going to point to what we call a frame, which will then contain all of this information, as well as any potential modifications. I will have to, let me get the map out. Oh. Our map was deleted. I wonder why. I wonder what happened. Come on, GIMP. Load up. Oh, hey, that's fun. All right, here we are. That's a bit large. Let's shrink it down a little bit. There we go. That's a bit nicer. Oh, too bright, too bright. Black. I bet that's way too bright. Okay, all right. We're here now. Let's get out our pen. Oh, that's a bit too large. Let's shrink that. Okay then. Alrighty. So, the idea is that we have our... I know what happened. Let's undo that. Okay. Alright, that's a bit better. Okay, so what we have is we have our dictionary. I'm going to brackets. We have our dictionary, which has all of our information in it. And at the very bottom, we have a final dictionary, which has a list of images. And this is connected to a component. I think I'm going to decrease the size of this a bit more. Yeah, that's a bit better. Oh yeah, that is better. All right. So then, with this dictionary, we can import this into we're still going to call it animator. But what it will do is this will contain a file which will tell us what is the backend. The backend for image manipulation can be CV2 or it can be Pillow. And then what it'll do is once it takes this in, it will convert these into frames, the framer. And then from there, we can then just do what we want to do. I feel like one of the key things is each individual frame can be modified. So, as such, this animation tool, it will have to have something called load presets. Actually, I think maybe the framer will have this. Yeah, I think that's what we'll do. I think the framer will have the load presets. And then from here, these can just be saved as JSONs. And then we can load them as JSON. So save presets, then load presets. And then from there, from there, we can, I'm going to have to change that. It's very annoying. But yeah, from here, that means each individual frame can be modified to however we like it. And we can set up a variety of different presets, for instance, changing the color of a particular frame, or changing a color of a particular layer, changing how the composite is at the very end. You know, these tiny things like that. And, we'll have to think of a way to structure it. I feel like because each, yeah, we'll have to think of a way to structure. Oh, I know. Oh, I did it again. I think what we can do, because each individual layer or component, which happens to be like the tail, the eyes, the body. Once we load it in the framer, these are actually dictionaries. And these contain information like the location, the, these types of things. Location, or path location, so that was the file location. The XY coordinates on the image. The, okay, yeah, I'm going to change. Let's see here. What is that button? That's very annoying. I'm changing that. Come on, GIMP. Where is the... It should be edit then. Select. Not page setup. Oh, come on, GIMP. Where is it? Come on. I see image properties and metadata. Select. It should be in... There it is. It is at the bottom. There it is. Preference. Okay, I'm going to change this real quick. Sorry, you're going to have to see something. I want to change the hotkeys. Import, exports, display, icons, themes. I'll do it later. I'll have to do it later because it is but anyway. So we have a general idea. So let's go ahead and start working on that. So first things first. Animator is going to be even more simplified. Because originally I was going to be separating it out. For instance, we have CV2 animations, we have animator, but no, we're not doing that. We only need the one, animator. We'll have to copy all of these things over. Yeah, we'll have to copy all of these things over. So this can stay as it is for now, but for this is the animator. Image, see here. I'm busy thinking for a sec. All right, well, let's go ahead and do this. So what we need is this is going to be the image manipulator, or let's call it what it is. So yeah, this is the image manipulation core. Would we call it a core? We're going to call it a we'll just call it image manipulation, and this will be an image manipulator. And then from here, let's go ahead and bring in image manipulation. There we go. This is going to be a service. So here's our constants. Well, actually, these are not constants anymore. So animator, we have the different layers. Yeah, this is all getting changed up. I think the purpose of the animator is to just make things relatively easy. We might end up compiling this somewhere else. The main thing is that everything's going to be dealt with the framer. Let's go ahead and start modifying framer up. This has to be significantly modified. Actually, I actually don't even think this is going to go on here. This reminds me a lot. All right, the code is beginning to look. The way I'm thinking about it is beginning to form like I had done it last time with the old sequencer and the framer and such. So let's just go ahead and clean the code up a bit, and maybe as we go through, things will start forming or getting together. The first things is separate out image manipulator. So let's see here. I think we'll just separate it out between image manipulator or just image manipulator, because technically there's two parts of this: how you modify the image and then how you visualize it. You can use CV2 to do all of your modifications and then visualize it using Pillow, or likewise you could do all your modifications with Pillow and then visualize it with CV2. I don't think there's much of a big difference between them, especially for given what we're trying to do. Maybe we'll have to worry about separating it out later. In fact, in order to make it easier if we want to do that later, what we'll do is we'll make sure that none of the visualizing of code will interface with any of the modification of the images. That way, if I have to strip it out later, then it should be very easy. And it makes sense to do it that way. So let's go ahead and do that. For our image manipulator, this is basically going to be an ABC class. So this is going to be an abstract basic class. Actually, where did ABC go? There it is. Okay, at the very top. So yeah, and we should probably get out our abstract method as well. So let's see here. Actually, if you look, the manipulation stuff right here, for the image manipulator, for the most part, it is fairly the same. So what I'm going to do is I'm going to grab you, and this is going to be this is going to be like that, and this happens to be CV image manipulator. And then let's copy that. And then this will be Pillow, so PIL. All right. Oh, we're missing our... There we go. Now then, this find coefficient is going to be present in both of them, so it doesn't really matter if this is present. Get shape here. So, all right. I'm busy thinking, because it's going to be a lot of functions that will just be inherited over. I think the main part is, yeah, I'm looking right now. These utilities right here seem to be fairly easy. We don't have to worry too much about them. It's here, like warp. So I'm going to go ahead and copy warp. Let's go ahead and put it over here. Now then, if this is an image union, yeah, I think this makes a bit more sense. Because now, since everything we're going to be doing here is CV2, that means if we find our image and we find out that it is, this code here becomes a way of converting our image to the format of needed for processing. Ah, I'm thinking. Hmm. I am pondering. I'm also making sure everything is running. Yeah, I think everything is running. I think that would be fine. I'm trying to think because so this is what I'm trying to think about. Should, when I input an image, should it output the same image format? As in, if it inputs in an ND array, should it output an ND array? If it inputs a image file, should it output an image? Part of me feels like I should just say no. But all right, I have an idea. So what we'll do here is we're going to look to see if this is an ND array, then what we can do is we can do things perfectly fine. No worries. We should probably still have our log here saying that it was warped. So image warped. However, if we're going to run this, we're still going to, let's see here. Let's see here, this is PAPB. And then we do the get perspective, which would be our warp matrix. And then warp image. So I'm going to put this down here, because at the end of the day, we're going to be doing that for both of them. Oh, we should probably get rid of warp. This should just be warp underscore warp. Actually, I don't think. Yeah, I don't think I think what we'll do is grab that. There we go. Now the whole reason why we did that was to separate it out, but since we are here, I have a suspicion that we probably don't need to do that here. Let's go ahead and grab these two. We'll replace that. Now this is warp image. All right. So this is, we don't need to worry about the shape because the shape is going, in fact, since we're doing this here, we can probably, actually, this actually, because the way we're building this is going to be in, Framer is going to be, this is going to be in, from Framer. So the idea is that Framer will have a lot of information, and that will be passable into our code here. So in other words, we won't need to worry about the image size because that will be something that will just be available. So here we go. Here's our image. In fact, I think that we still need to pass in the image. So we'll go here. We'll pass in the image. We'll pass in image size. This will be a tuple, which will happen to have 2 ints. There we go. All right, so far so good. I see this as complaining a bit because it's a bit long, so why don't we cut that down? There we go. Oh, now what are you complaining about? Oh yeah, the signature doesn't match. Yeah, don't worry, don't worry. I am working on it. So now here we have this where we get our transformation. Now, because of the fact that this is going to be done no matter what, so the main thing is this. So yeah, let's go ahead and bring this and put this down here. The main thing is this. If this image is a... Actually, one moment. I'm going to go ahead and grab that. We can put this down here as well. There we go. Now then, if this is an image, then I don't think we need the error log. I'm trying to think. Because the idea is that if you well, this is technically, again, this is going to be something that you input into Framer. And because of that, we won't have to worry too much about... No, it really should be there. Ideally, if this is an ND array, that don't do anything. If this is a image, then we need to convert this, and we'll have to comment that here. So past file is image format converting to ND array. Then from here we'll go image. Actually, how do we modify it? Let's see here. Let's go with Python pillow to ND array. Hey, this was a question asked on Stack Overflow. Nice. Here we go. This is because put data expects a sequence of tuples. Okay. NumPy array pick. It works, but is very slow. As of PIL 1.1.6, the proper way to convert between images and NumPy arrays is simply turn it into an array. All right, that works very simply. So from here, we just need to do np.array image. And then from this, we'll simply call this image. Now, I'm going to go ahead and move this down. There we go. That way, if it's a NumPy array, we don't do anything. If it is an image, we convert it and then tell people that we converted it. And then from here, we then do our calculations. And we also tell people, hey, the file was warped. And then for our inputs, it's simply image and here, yeah, it's image, PA, PB, and image size. All right, and the reason why we need image size is because of how big our warp image should be at the end. Technically, I could collect it from here, but I think it would be better to just pass something in, because I'm always trying to think of ways to reduce the amount of, every time I have to call a function, that means it's just might be a millisecond here or a millisecond there. And I know it won't be too long, but if I can decrease the amount of calls, it just makes the program run better. So actually, thinking about it, plus, I just thought about this. Because someone might want to not just keep everything within the same frame. They might actually want to extend the image or something. So it's good to have the image size as well, so that for people who want to modify it, then they can. Oh, I see spam. Spam. Oh, nope. All right, spam. Congratulations. We're going to get you. Oh, no. We're going to get you. Spam. Bot. Is a bot. We are. There we go. And now we're going to also ban you. You be gone. Aha. Okay. He's gone. Be gone, bot. Anyway. Let's continue. So now we have that an idea in mind. Let's go ahead and copy this. Let's bring it back up here. Right here. Oh. There. And this is going to be a abstract method. So technically, this is going to have to be a pass, because this is an abstract method. We're going to be modifying it and changing it. So with that in mind, this section here is done. Let's go ahead and grab the next bit. Let's head on down to this class here. Oh, we should probably copy this as well. There we go. And there. So with that in mind, so in this case, if it's an image, in this case, if it's an image, we're just going to pass this. And then let's go ahead and grab these. Actually, we want this to be here. Oh, we want this to be here. And then the else statement can stay there, like that. That works well. Now we have, there we go, that works pretty well. And then from here, let's see here. This happens to be the pillow calculations. Now this is an ND array, so this needs to be down here. So image warped using pill. I don't think I need to say using pill, because you input it in. So we just need to say image is warped. Let's go ahead and grab that. Oh. So there we go. Converting to image. This was ND array. All right, so now what we need to do is do the reverse. ND arrays to, now we need to do the reverse. We have the ability to go forward simply by numpy and then array. So how about the reverse? Oh, this case, they say as array. Open I as an array. Do some stuff to I, then convert it back to an image. Ah, here we go. So pill image from array. There we go. Perfect. Hey, nice. We got the other direction. So let's go ahead and copy that. Actually, you know what? We're going to type it. There it is. Let's see here. I've imported in pill, didn't I? I've imported pill image. So pill dot. This is why I wanted to type it, because if I don't remember it within a second after finding it, then I'm definitely not going to remember it when I have to do this later, and I'll have to be running the exact same search. So it's image from array. We already imported an image. And because of that, we can go image from array, and then this will be image. And then this will then simply output this like so. And with that, now we have the warp function for both of them. We have warp here, which is going to be modified, which will, let's go ahead and do that. We have warp here, which is going to be using pillow. Oh, actually, we should probably grab the code from there. Yeah, so we don't need that anymore. We want this. Let's see here. Here it is. Don't need that. Don't need that. I should probably keep the... Probably should keep these the same. There we go. So yeah, here we find our coefficients. We then output our image. We then return it. So yeah, this one uses an extra step. Or actually it doesn't. Actually, it doesn't really use an extra step. All right then. All right, I think that's good there. So now warp has been parsed. Let's go ahead and parse the next one. In fact, we can delete that now. Here is our bounce, and that can be part of the image manipulator. Ah, here, get shape. What does get shape complain about? Is a static function actually... because we're going to... We should probably look at our framer. So the idea here is we're going to... Let's go ahead and put here. This is a service. And this will be image manipulator. And then this will be... Let's see, let's grab our class. This is going to be one of these. Yeah, let's go ahead and import. So this is our image manipulator. Right here. This is going to have a variety of different classes. This has to be brought in. So when we initialize... Oh, okay, where is this manipulator going to be? Okay then, let's think. Let's think. This is just a module. As in, this is just code. So it has no memory attached to it. That means I can have it attached to every single frame and then do whatever we want internally within each frame. This is originally how we were planning to do it. Because if we wanted to, if this was going to hold, it does hold some amount of memory because it, however large the file is, it's going to be that within said memory. But it's not going to be it's not going to be storing like images or those types of things. So it's not going to bloat. It's just a package of code. So with that in mind, that means we can have it here. And we can just start calling them down here. And we can probably bring them into here. I think one thing we can do is all right, well, let's continue working. First things first. I'm going to... Let's see here. I'm going to put this right here. Self.imageManipulator equals... And then from here, we're just going to be passing it in. So image manipulator. Image manipulator. This needs to be... Yeah, this needs to be up here where there's no... like that. Alright, then let's go ahead and... Oh! Manip. I spelt that wrong. It's amazing how that happens frequently. There we go. Alright then, so now we have our image manipulator present. Then from here, whenever we want to do something like warp an image, we just call this. So where is warp? Add layers. Show. Here it is, warp. Originally we were doing a if you can see here, originally we were doing a transformation. So if data is none, then return image. Yeah, okay. Is warp being called anywhere? Oh yeah, here. It's being called here in show. Oh my. In other words, I was doing the warping. Oh, no wonder why it was so slow. I was doing it during the show function, so... I'm thinking. Because... Alright, how about we do this? Let's go up here and start modifying our variables. So we need to have... We have a couple variables. We have the frame name, which is supposed to be a way of identifying what the frame is. I don't think we need to know what the name of the frame is. I'm sorry. We set the data up so that we know exactly what the frame is. Yeah, we set it up exactly to know what it is. We already have everything in sequence, so we don't need to worry about the name. We can get rid of that. In fact, I don't even think we used it anywhere. Well, okay, we did use it here, but this was when we were trying to reproduce it. I don't think we need that. There we go. In fact, I think we don't even need the well... This might get modified. So what I'm thinking of... Let me show you what I'm thinking of. So let's get back over here to GIMP. So we have Framer right here. Actually, you know what? Why don't we make a new frame? I'm going to have to modify my thing a bit. All right, here we go. New frame. All right, here we go. Let me move the mouse out of the way. All right, so here we have something called Framer right here. And this is going to be this is going to contain all of our information. Now, what I would like to happen is that we're going to have two individual images. This is going to be the pre, and this will be post. Every time we call something like show, or if we just called framer, it will output this file right here, the post. This way, when we want to do something, it will automatically generate out what we want. It will be stored. This pre is if we decide we don't like what we did here, we can go reset, in which case it will then push the pre file over. And technically pre is going to be however many files are present. I have a feeling, because this is what I was talking about earlier. This is like a certain level of bloat that will quickly drain resources on any computer. Because what happens if I have 100 of these individual components, all of this being stored in my RAM? Like, that is so many arrays being stored that it's going to just, it might not be too bad. It might not be too bad, because most computers nowadays, like their GPUs are super powerful, and you can do millions and billions of array calculations in a matter of milliseconds, especially with a GPU. But I'm using Python here. Python, I don't think Python let's actually do a quick check. If I can, I just had a brain fart. Let's see here. Python CUDA image manipulation. CUDA for programming environments. For those who don't know, CUDA happens to be a you can actually see it right here. CUDA programming for Python. Let's see here. If you're curious about GPUs and CUDA, this blog will help. All right, so Bergrum, I hope you will explain. No. Here you go. It's a computer unified device architecture. It was created by NVIDIA for NVIDIA GPUs. If you're going to do anything with AI, you'll most likely end up using CUDA, because this offloads a lot of your programming to your GPU. This is often called the GPGPU, or General Purpose Computing on Graphics Processing Units. See, that's what I just said. So let's see here. One of CUDA's strengths is that it organizes parallel tasks. What is a parallel computing? All right. Actually, what I want to do is store images into the... What I want to do is I want to store images in there and do all sorts of calculations. Though, to be fair, it might be a bit overkill. A CPU is like a Ferrari, fast, nimble, great for small jobs. A GPU is like a truck. Slower to start, but capable of carrying tons of data at once. And that's kind of what I was thinking of. Especially if you look at the idea here. Especially if you think about our idea right here. Because of the fact that I want to... So let's just look at this example. So I have a whole lot of frames that will eventually become a pre-post, and then this will be processed later as a post. The idea is that if I do something like, again, warp it, or stretch it, or that's what warp is, but rotate it. If I do any of these types of things, it will be stored here. So whenever I call, it will always display it. And I don't have to keep rerunning these functions. I can do it one time and then just call to collect the data. Actually, wait, this might be for... Thinking about it, this is, I'm thinking in terms of building it for animating. This is just for creating videos, so technically I don't need to have anything loaded in memory. I just need to know how to process it, and then I can load it up individually and then output it. So, yeah, so this really just needs to be a pipeline. All right then. So technically with that in mind, maybe I won't have to worry too much about RAM. Anyway, let's go ahead and continue. All right, let's continue. So with that in mind, these actually don't need to be kept in memory. And this here doesn't need to be kept in memory either. If we want to redo it, then we could just rerun everything from scratch. All that needs to be left is the post image. So yeah, all I need is this one file right here. This right here. And this is all for loading. So if I want to do some kind of modification here, then I can say, hey, modify this while you're compiling, and then we can then do the post-processing afterwards. So with that in mind, that means all we really need to do is worry about, let's see here, background color, components, composites. Yeah, I think that might... Yeah, see, I was running compile every single time when we want the composite, so I don't think we need that either. So what we'll do is we'll change the let's see here. So, all right, components. First things first, where is components? What is components doing? Here is components. Where do we populate components? In the compile, for layers in components. All right. I'm going to go ahead and delete that for now. So, all right, so there's components. So where is, here we go. This is reordering the layers for the different components. And then here we go. Here's add layers, add layer, add components, add... Oh boy, why are these separated? Why are these separated? Why do we have add components and then add layers? All right, does this get called within add layers? No, it doesn't. Yeah, this is a giant mess. Okay, and then this is preset. We can keep the presets for now, but I'm just going to... Yeah, I'm just going to delete all this right here. We do not need this. We do not need the add components. We do not need the add layers. Let's just get rid of all that. And let's go up here and start cleaning things up. I don't know what I was thinking with this code. So yeah, we don't need components. This is called composites. This is what the image is going to be. So we're just going to change this to image. Background color. So background color. Oh. Background color, background color. if I have background color separate out into this, then I could change what the background will be on the frame, which would be fine. And then I could also tell it to output just without it. But do I actually need to store this? I think it would just make more sense to say add background and then, or yeah, compile and then give it a save, you know, with a background. So yeah, we don't need the background color. So yeah, we don't need that either. Warp presets. That should not be here either. Okay, so this was originally for, okay, so there we go. Yeah, we do not need background color. So let's go ahead and get rid of that. We don't need components or warp. Mode. Change bit depth. Image size. So for image size, I think, but this will be a bit interesting because ultimately this is going to be independent from the layers. So I guess we can keep that for now to say what our image size will be. All right. So let's see here. Bit depth, image size, image mode. Okay, let's go ahead and start getting rid of these. We don't need components for the properties. This is now going to be image. So let's go ahead and change this to, this is actually, we'll call it image for now, or actually, this is kind of what I was talking about. If this is going to be a, let's see here, this is framer. I'm thinking. Let's see here. Image size can be a property. We don't need background color. That doesn't need to be a property. I don't think this needs to be a property either. This is supposed to be a hidden variable. Whenever we call it, so let's see here. Rep R. So I believe, all right, let me do something real quick. I always used rep R for producing strings, but I now want to use it to output an array. So here it is, using the repr method. In tutorial unit, okay, it's a dunder method that defines the behavior when you pass an instance of a class to the rep. The rep method returns the string representation of the object. Okay then, so yeah. So this has to be that. So what are the other dunder methods? Where, let's see here. Dunder method. Here it is, Python morsels. Every dunder method in Python. All right, so let's see. Where are you, dunder method? So this isn't, we don't have to worry about operations because this is going to be, yeah, this is a container. It's not, so we're not going to be doing that. Enter when you're given as, nope. Exit, no. Let's see, length, iter, item, next, yeah, the get item. Actually, the one I'm looking for is just when you type the thing in. For instance, if I type in X, and it will output it what it is. Not an operator, not an operand. In place. No. No, not those. Not that. Let's see here. None of that. Not a buffer. I probably should keep this actually stored somewhere so I can use it later. Hey, Elastic Splash. How's it going? I am trying to... So what I'm trying to do, I'm looking for the dunder method where when I assign a variable, it will output that variable, it will call that. For instance, if I say x equals 5, then when I type x, it will return 5. And what I would like to do is when I call my framer function here, when I do, for instance, when I call framer, instead of outputting the rep, which would happen to be the string, which will say what it is, it will return an ND array or a pillow image file. That's the idea. That way I just have to call it. I don't have to type in like framer.getImage or I don't have to type in like framer.getImage or in this case I put a show button like here show. And I even had compile earlier, which was to output the image. I'd rather just type it in and get it called. So I'm looking for that dunder method. I was thinking it was rep r, but that just sends out a string. For assignment, math, category. Oh hey, Picklake. This has a lot of the... Alright. Back week, up we go. So these are the 3 essential ones. So equate, rep, which is not what we like, and initialize, which is not what we're doing. So you'll almost never see an E implemented. Oh, not implemented. All right, interesting. String bullets. These are the dunder method calls. All right. Well, let's go ahead and start. Let's go ahead and we'll worry about that once we get there, I guess. The main thing is, let's see here. The main thing is, here we go, compile. I'm going to go ahead and just start completely emptying this out because we don't need half of these. Channel check. Raise about it returns at one usage. All the way here when we're generating a color map. Oh yeah, this was for the background. I don't think we need that. Here's colorize. Actually, colorize. That should be moved over to the image manipulator. So I'm going to go ahead and cut this. Let's get over here to our image manipulator. There we go. So let's go ahead and call this colorize. There's the color types. Let's see here. If I remember, Framer has the color types right here. Let's go ahead and get in our typing for union. All right, so now what we need to do is start parsing this out. So this is also going to be an abstract method. So in this case, we take our image, we take our color, and then we start doing things. So let's go ahead and copy this. It looks like this was the pillow. Yeah. This was pillow code right here. You can tell because it has image ops and, image.image. I see I did a split to get the alpha. Let's see here. Is alpha used anywhere? Here it is. It's where we put alpha back in. Ah, okay. I think that might have to do with... I think that might have to do... Yeah, I see. All right. So let's go ahead and... I'm going to go ahead and copy all of this. Then we'll go ahead and change this to pass, since this is going to be a abstract method. Let's head on down to our... Here it is. To the pillow. Our pillow image manipulator. What are you complaining about? Too many blank lines. Oh. There you go. Now then. So originally I was checking to see... I get it now. Alright, so originally what was going on here is because of how Colorize works in image ops, it would always output a... I believe it would just output an RGB image. So I ended up splitting out the alpha and then putting the alpha back in so that I could keep it a RGBA. So I think for this, I don't think we need to worry about... What I'm going to do here is we're going to put here is... I'm going to call it... this is going to be a toggle here. All right. What I was thinking was adding in a toggle to tell it to keep the alpha or not. Let's bring in image ops first. And let's also bring in our enum, or image enum. Well, I don't think we need the image enum this time. That's what I'm actually trying to figure out how to get rid of. Generate color map. Oh, okay. I deleted that, didn't I? Yeah, I think I deleted that. Generate color map, didn't I? Yes, I did. I deleted generate color map. Let's hop into our... It's a good thing that I... Let's see here. It's a good thing that I set a checkpoint. Here it is, generate color map. Let's copy that. Let's head back to our image manipulation. Let's put this here. Now then, check channels. Background color. All right. So, yeah, this code, my old code, man, me writing this code a year and a half ago. What was I thinking? This code is makes so little sense sometimes. I'm checking the background color, so this is what this is doing. So that I can then return the background color. If this is a string, then I would get the RGB. The idea was, I could just type in red and then it will generate the red. Or, oh, I could type in pink and it'll generate the pink. Yeah, I know what you mean. Looking at old code sometimes, you're like, okay, why did you do it this way? What made you think this was a great idea? So generate color map is just the background color. So I feel like this is actually doesn't need to be here. And I feel like this doesn't need to be here either. Let's see. For colorize, oh, a moment. Let's see here. We bring this in, the color. We already blocked this out, which means we were looking for a tuple. So in other words, this colors, let's see here, this colors was going to originally be an RGB, like that. So that's what this was looking for. So this happens to be, I'm going to just go ahead and call it what it is right now. That way it'll make things a little bit easier. All right, so that means we don't need that. We just need to bring in, let's see here. Just call it color. Now this happens to be us trying to get the alpha out. So here's a question. I know how to do it with, yeah, this is, all right, this is going to be a bit of an interesting question here, because the image manipulator is supposed to be completely devoid of what, the idea is that the framer will contain the info. For instance, we have our mode, and this mode will be one of these. It will be a 1-bit, grayscale, RGB, or RGBA. So if it's RGBA, I can see why a lot of image processors, they tend to just kind of hyper-focus on one format, because it becomes quite a convoluted when you start trying to figure these things out. Because I want to just do it all as an RGBA. I think I'll have to potentially have some, I might have to have a module, that small tiny modules. Yeah, I might have to have small tiny modules that are all dedicated to the different types. And then when I go into image manipulation and say, hey, colorize, it will just go, oh, since you're looking at RGBA, then we'll just grab all of these things. That way I just have this. I think that might be what I might have to do for now. Let's just put a to-do here. And need to change to accommodate different image modes. And then for now, this is just going to, we're just going to assume this is a, so currently assuming RGBA. All right, so here's our image. And this happens to be image. I see. Yeah, that is true. Yeah, well, the idea though is I've that is true. That is true. The idea though is that the image manipulator code, it will all be, once you set up Framer, you'll just be importing it in. So the idea is that I'm going to call Framer. I will input in what the manipulator will be and then run it from there. So theoretically, this is all back-end stuff. I don't think anyone will be, no one should be seeing this, I believe. At least that's under my impression. All right, we're going to go ahead and put that back in. There we go. So we split out our color. Oh, and this is going to be outputting an image. And this should be an image union, actually. So image union, because this is going to be colorized. Let's see here. Here it is, right here, colorize. There we go. And what are you complaining about? Must implement all oh yeah. I know. I'm working on it. So we need to now implement colorize here. All right. Let's see here. So there we go. Now, because this is going to be, let's see here. So there's our warp. You know, I'm going to have to be calling this code every single time. So let's go ahead and add in a, this is going to be another, I don't, actually, let's see here. Yeah, the way that this is written, okay. So what we need to do is we need to have another abstract method. We'll put it down here in the utils. And this will be, I want to say correct format, but that's not a good name for a method. Let's see here. Okay, I'm just going to call it that for now. Correct format. And then this will be image. And this will be an image union. And then what we're going to output is we're going to output an image union. Okay, we're going to pass this. Let's go down here and implement this down here. Let's go ahead and grab this code. So I'll go copy that. We'll paste that here. And then we'll simply return image. So the idea is that if this is a the idea is that if this is the correct format, as in if this happens to be an image.image, don't do anything, just return it. If this happens to be a numpy array, then convert it into an image, tell us that what it was wrong, and then return it. And then from there, all I have to do now is just run this here. So image is equal to that. And then from there, I can then proceed to put this here as well. And I spelled that wrong. I don't care. Okay. And then likewise, we can do the same thing here now. Let's go ahead and grab this. Put that right here. Grab you in here. Self dot correct image. There we go, and then we can also do that right here. There. All right. Oh, this should be image. There we go. Okay. All right then. So now we have that. So now we just need to do a. Oh, now we just need to do a colorization. So let's see here. So let's see here. Now we just need to colorize. So because this is going to be, oh, and this needs to be a, this is going to be a numpy array. Let's see, colorize up here. So this needs to be image union. Actually, there we go. And then here, this needs to be as well. But yeah, what we're working with here are numpy arrays. So now that we're here, all right, how does CV2 do its colorizations? So CV2 colorize image. I have a inkling of how it would do that. Yeah, here we go. That's exactly what I want to do. Convert color. No, that's not what we want. How to colorize a grayscale? No. Expand colors. Actually, wait. Will we just change them? I don't think we would. I don't think we'll change the namespace. What we just want to do is CV2 change color. Via colorize. Hey, another Stack Overflow. Let's check that out. I don't think that is what... Change colors of an area in an image using opencv. I kind of wish that they would have... I kind of wish that the person who generated the question would have given an output on what they wanted to do. Well, let's see here. Convert to HSV color space. Threshold on desired color to make a mask. Use the mask to change the color of the corresponding pixels. Then draw a new rectangle. Actually, I think that might be what we want. Or maybe that might not be what we want. Yeah, okay. That might not be what we want. Let's look at it, though. It might give me some hints. Let's see here. So first thing it does is it converts our image into an HSV. Then we find the sensitivities. Then we do in range. We then copy and mask. Then we'll create a rectangle. That's all showing, and that's all writing. I think that's pretty close to what we might be wanting to do. Actually, one sec. I have an idea. Here it is, colorize. So why don't I look at this? I'll simply do opencv to code that. I'm just going to put these two together. CV2 image colorize. Converting image. Nope, nope, not that, not that. How to colorize a grayscale. No. Actually, that might be it. Actually, that might be what we want. What I could do is I could grayscale an image and then convert it, and then convert it to... Actually, that is a good question. When I do colorize, I think that's actually what GIMP does, isn't it? One moment. Let's see here. Here we go. We'll grab you. Let's put down a couple colors real quick. We're doing the test. Here we go. We'll put down green. All right, so there we go. Green. Yellow. That's actually a bit more gold, but anyway, you know what I mean. We'll put down this color. And blue. There you go. Looking like a Super Nintendo controller. And then from here, we'll simply go image, and then colorize. And it... All right, yeah, so it did do that. Now the question is how is it doing it? I have a feeling that it's grayscaling it. So first thing, so let's try and do that. By grayscale, okay, I grayscaled you. Oh, it crashed. There we go. Yeah, that's what they're doing. All right, yeah, that is exactly what they're doing. So that's what we should do as well. So let's go ahead and unconvert that. So yeah, that's exactly what they're doing. So what we can do is all right, so first things first, we have our image. So we'll want to grayscale. Then we'll want to apply color to it. So apply HSV and then return it. So that's kind of the steps that we want to do. All right. So let's see here. The CV2, here's our... This can actually be the second step first. In this case, I want to colorize this. I wonder if this actually got an answer. Hey, it did get an answer. All right. So here's their color image. There's the background. Then CV2 color. And then this is where they change it. They get the alpha out. Put the let's see here. Multiply BGR with image color. So they would did a multiply. Okay, maybe I'm a bit dumb. I'm just sitting here thinking, I'm looking at the code and trying to figure things out, and I'm just sitting here thinking, what's going on here? I think the main thing is like, what is multiply doing? I see background and I see image color. Background happens to be the first three. Yeah, if you look here, this happens to be the first three. This isn't a... I wish they would do typing. Typing is so nice. It helps keep things... It makes things so easy to understand. So here we have an array. This is our NP array. We're then dumping our NP array into here. image color happens to be, it looks like another NP array. In other words, this is supposed to be pure blue because it's a 1. So this would be our, and then from here they then do a multiply between their grayscale image and their, yeah, they do this. So they convert this first to a float, do multiplication, and then convert it back to an integer. All right. And that's because of the multiplication. Well, I guess why not give it a try? All right, so, and then lastly, this is putting the alpha back in. So, again, since we're assuming right now, so that means this right here can be kept up here as well. So first things first, we're going to take our image. So cv2 dot, let's see here. Oh, what does color change do? Actually, what does color, again, I'm just, all right, let's see here. What does color change do? cv2 dot color change. Yeah, here it is, color change method. Given the original image color, the color image, 2 different colored versions of the image can be mixed seamlessly, manipulating factors from 0 to 2.5. So from here, that's C#. What about C++? Oh, okay, interesting. Let's see here. So color change, our input array is the source, then we have our mask, our output is destination, and then we have red, green, and blue. Wait a minute. Wait, can I just use, did they already implement what I want to do? I'm going to try that. Let's try this. So here we have color image. What's the inputs for this? So our source, which would be, we have our source, we have our mask, which would be the alpha. Then we have the destination, which would be our, actually, I don't think we would have a destination. Yeah, it can be a none. And then simply the red, green, and blue. And then this will output a matrix. Okay. All right. It looks very, I think it does. I think it's going to do what we want. So first things first, we're going to put in image. So that's what we're inputting in. And then the mask happens to be, when it says mask, it could mean 2 things. It could mean the alpha channel, or it could mean the, or it could mean, I'm going to use the alpha channel. That's what I'm going to do. So first things first, let's go ahead and we'll say here, we'll have 0. Let's see here. This is 3. Let's see here. So we want all of the first one, all of the second one, and then we want to go to, we want to grab the first 3, and then this one will be all of the first, all of the second, and then the last one. And then this is output, but we don't want that. We want to do the red, green, and blue. It doesn't look like there's an alpha. Now then, what I'm going to do is we're going to change this to, this is a tuple. So this will be our GB. But this is going to be an int. This is also going to be an int, and this is also going to be an int. And then this will simply be R G B. And then from here we'll simply output, and this we'll call this, what did I originally call it down here? GS image. That doesn't make, what does GS mean? Oh, grayscale image. Oh, right. Oh yeah, I definitely did that here. I grayscale. Yeah, that. So yeah, I did. I grayscaled it. Then I applied a color, and then I added the alpha back in. I'm gonna call this. That way, it will make. That way, I won't. It makes things a little easier to understand. Granted, it's not a grayscale image at the end, so... Actually, you know, I think I just put, what, Shift F6? There we go, okay. We're just going to call this colorized image. There we go. And then from here, we also do the same thing. Colorized image. And technically, this is not going to be this is going to be a ND array. And then from here, I really need to do some tests to see, because I don't, what does CV2 do? So import CV2. Do I have an image loaded anywhere? I have any images. Come on, any image. No images. All right. Let's see here. I think in the in the animator code we did have load images. So why don't we go ahead and run this real quick? Actually, let's create a new Python first. There we go. Oh. Image manipulation partially installed. Oh yeah, let's go ahead and... Let's see here. Where is the image manipulator? Here it is. There we go. Now let's go ahead and... Did I move layer import? I think I did move it. Let's see. So... from src dot importers layer importer. There we go. And then let's go ahead and just resolve these as well. There we go. All right, let's load this up. Layer importer not defined. There we go. Okay, image is loaded. All right, image is loaded. So there it is. There's our image. It's a big image, but there we go. Perfect. So now we have our, that's comp image. So let's go ahead and start messing with the comp image. So let's see. What is comp? That is an ND array. So we are already where we want to be. So, all right. So what I'm going to do here is I'm going to grab image, comp, and then color is going to, what do we want this to be? Let's make this Let's make this cyan. There we go. All right then, so now we have that. Let's go ahead and run that. Now, let's see here. For our animator, we have, I called it self. So yeah, so let's do self dot show image colorized image. Now let's see here. Did this work? Kinda. Why is he have an afro now? And why is that green? Like, something went. So it kind of worked. I'm very curious about what all that is. I mean, yeah, okay, we have half of it. We have half of it. I wonder what's happened. It looks... Yeah, let's go ahead and see here. I think what I need to do is... Oh. Yeah, it's already... Yeah. It's already an RGB, so we don't have to worry too much about that. Maybe what we should do is we should first... let's see here. Go with image. The mask was what I first... Yeah, it was the mask. What does the mask look like now for image? Actually, let's see here. Let's see here. Let's view this as an array. These are like individual pixels. Okay, here we go. All right, so is that giant blob? What is that? This should be his face. And that should be that should be like one of the ghosts. Yeah, you can see there's the whiskers up. There's the whiskers. Yeah, so that's the ghost. That means that was the head. Then what is that? Or that should be the VR headset. If we go this way... Actually, no. What is this? All right. That is, interesting. What is that? What is that? I don't see anything up here. Let's see. Was I looking at his tail, maybe? I think I might have been looking at the tail. All right. So that means none of the other bits should have any color in it. Oh, whoops. Let's restart that. All right. So with that in mind, let's go back here. So I guess what we'll do is we'll go with colorized image is going to be... so what we'll want to do is we'll want to output the alpha, which will happen to be this. And this is just going to be a ND array. And then for this is going to be colorized image. So there it is, colorized image. And this is also going to be a ND array, but it's going to be this set. And for us, we want to go cv2 dot grayscale. Let's see here. Not change color. Where's gray? Where's gray? Gray. Not IM read grayscale. Ah, here we go. It should be RGBA to gray. I see gray to RGBA and BGRA. But where is the to function? Oh, here we go, Bayer. I see I don't see a basic to gray. I see that all the different formats. That yeah, that kind of sucks. That means I'm going to have to structure it a bit, so we'll keep an eye out for what the format is going to be. For now, as I said, we're just getting something down. So why don't we go with this one, BGR, this one right here. BGGR. What is... I don't see it. We're looking for BGRA. There's BGR. Here you go. BGRA to gray. Alright. Then from here we'll go with that. And then that. And what are you complaining about? Int object not callable. Ah, I get it. This is something else, isn't it? All right. All right, let's see here. I don't often use CV2, so I have to... Let's see. Is there a... Yeah, they're doing a multiply here, but they're already under the assumption that their image is gray. So let's see here. Whoop. CV2 image to gray. Converting an image to grayscale. There we go. CV2 image. All right. CVT color. Hey, they have a... They just do IM read grayscale. Oh, that's the question. Got it. All right, CVT. Okay. So CV2 dot CVT color. There it is. And then we'll want to have in image the code. We don't worry about the other ones. There we go. So there we go. Now and we don't need this now because we already know what our type is, so we don't need that. So what we do is we have that, we then that, and then we'll have to convert this back to a, and then from here it's going to be gray to RG or BGRA because that's what we're working with. And then I think last but not least, colorized image. the final, and simply this will be alpha, like that. There we go. And I think from here, do we really need our mask? Yeah, we do. Okay. Yeah, we need the mask. All right. I was kind of hoping I wouldn't need the mask, but it looks like we need the mask. I wonder if there's a... We'll keep it like this, like it is for now. We don't need that. Colorized image can go there. Okay, let's go ahead and run this. So we have comp, we'll call it image. Can I do... Nope. All right, that's fine. That's fine. So, color. Now, let's go ahead and change this. We'll go 0, 200, or we'll go 0. That cyan was a bit too bright, so let's go 150 this time. Yeah, that was a bit too bright, so let's go with something smaller, 150. Now let's go ahead and run that. Then we'll run this. Oh, there's an error. What's the error? src empty. Function Laplacian. What's the error mean? It's when we're trying to change the color to colorized image. I wonder if it's because we we convert it to a grayscale. I bet that's the reason why. We converted it to a grayscale. So the first thing we need to do is turn it to a grayscale. Then we can turn it back. And then we proceed to do that. And then we add back in the alpha. Okay, let's try that this time. There we go. Now let's see here. Now, how does this look? It looks like our image is gone. Okay, what happened to our image? Step by step. Let's see here. First things first, we'll do that. Our image is grayscaled. We can see it's there perfectly fine. And then that means let's go ahead and do that. From here, our image is still fine. So now, in other words, the mask probably deleted this here. Okay, let's see what color change. Let's see what the mask actually is asking for. So here it is, color change, mask, input array. The mask is an 8-bit 1 or 3 channel image. So it's just an image. Most likely of the location that we want to. But the alpha is exactly what we need. That's the mask is our alpha file. Okay, why don't we do this? I have output alpha. Let's show alpha. There we go. There's alpha. All right, so yeah, that's our alpha right there. That should be it. And I noticed that some of the alpha is a bit not pure white, but I think that's fine. So then when we do this, okay then, so let's see, what is, let's look at colorized. Let's see here, what are the dimensions? Colorized image has 4 dimensions, all right. So let's go ahead and show colorized image now. Oh, that's alpha. Let's see here. We want colorized image, and it's gone. Okay, why is it gone? Okay, yeah. Why? Why is it gone? What? That's very strange. How much do you bet it's because... But the mask should be correct. We know that it worked earlier when we... Well, yeah, it did kind of work earlier when we were just grabbing the alpha. How about we do this? Let's see here. Color change. Let's see if there's an example available for this. Here we go. Convert color. Oh, this does a okay, that's yeah, in this particular case, they just went through each of the we could technically do that. Once I grayscale it, I can then go through the RGB and multiply it. We can do that and then do a multiplication. Actually, thinking about it, yeah, that's thinking about it, we could do something like that. It would be a very quick. Let's see if there's a how old is this? 10 years. Yeah. Let's see if we can use color change so that I'm not doing it in Python. I'm not doing it in Python proper. Nope. Not helpful. I'm a bit surprised that I'm not seeing anything about color change. Is this a relatively new function? That's 7 years old. CV2 color change is not a valid function for CV2. Instead, try and use CV2. But we were just looking at it. In fact, it's right here in the code. I have a feeling the AI models are not up to date. Let's see, how old is this? 2025, so a year old. So let's see here. In this case, they use CV2 color change, HV2 new. All right, here we go. So split image into... So what they do is they change it to HSV. They then split it out to HSV. They then... Let's see here. So they're just changing the colors of these two cars, huh? All right, all right. So yeah, they just use CV2 color. Okay. And then they merge the three masks later. I guess I could probably try and do that. But I would have to convert the... I would have to, I mean, it's easy. It's easy to do it this way when you want to change the colors like this, but if I have an RGB value, would have to convert it to an HSV value. I wonder if there's an easy way to do that. Here's the new H. So apply color image. So they first change get the HSV mod, then they clip. So V plus brightness change, then they'll merge. Then they convert this HSV back to BGR. That's the new background. All right, I'm going to see if I can find another example. How to change the hue of a certain area in Python. Actually, that's what that was just doing. All right, I have a feeling that I'm going to have to use... yeah, I have a feeling we're going to be using CVT as well for this. Let's see here. This is all the explanations. Oh. Yeah, there's the RGB. Then this is another RGB. Here's his code. Here we go. So this case, he's converting the... Oh, in this one, he split out the different channels. Yeah, there's the HSV. Yep, he's going to probably use HSV as well, isn't he? Yep, there it is. HSV. And then here he is modifying the HSVs. So there's H, there's S, and there's V. There's a composite. Then here are his calculations for doing the different colors. Let's see here. How did he do his grayscale? Oh yeah, it's just that to grayscale. Yeah, we already did that. Oh, we're already at the summary. Oh, okay, that didn't tell us anything. Okay, it told us a lot, but it didn't tell us what we were hoping for. All right. So apparently color change is they would not recommend color change. So if that's the case, then we need to change this to HSV. I am pretty content with trying to use color change. If only my mask would work. Here, let's try Google. Let's try Google real quick and see if it. Let's see here. Here we go. Oh, I have a strong feeling that I might have found something that is that not very many people use or know how to use. A binary image grayscale where white pixels define the area you want to recolor. Yes, I did that. That's exactly what we're doing. That's what the alpha channel is. So in all intents and purposes, this should be correct. Actually, let's see here. What is RGB? Here we go. 0, 150, 150. So that means B is 150, R is 0, and G is 150. Yeah, so this all should, for all intents and purposes, this should So So we know these two work. It's this one here. And we know the alpha works. Oh, actually, what is the alpha? Let's see here. np.max. Ah, that might be it. It's supposed to be a binary, but this is 255. I wonder if that might be the problem. So if that's the case, let's change this to let's go ahead and do that for now. And then from there, let's go ahead and run all of that. Or let's go ahead and run all of this. Oh, well, here we go. What is this complaining about? I'm gonna, all right. All right, let's see here. Show image, colorize image. And nope, it's still missing. Very strange, very strange. I don't know why I don't know why. All right. Let's see. It's 7 o'clock on my end. I have to start thinking about dinner. So what I'm going to do is I'll continue messing with this later and figuring it out. For now, it's been fun programming, and yeah, have a good one, everyone. I'll figure this out and continue with this going forward. But yeah, this is the general idea. We'll have set it up so that we'll have the two different image manipulators, one using CV2, the other using Pillow, and then from there, whenever we call Framer, if we tell it to use Pillow, then everything will be using this image manipulation tool, and if we have CV2, we'll be using the other one. That does mean that we'll have to update the code a bit, so that's for showing purposes and such, though I don't know if that will be necessary. But either way, it's been fun. It's been fun. Until then, have a good one. I'm going to figure out what this is doing later. Laters.